Okay, and welcome to this next part of the mechanics course where we're going to look at kinematics, which is basically the study of motion. The first video in this series will look at displacement time graphs and how we interpret them and how we can sort of draw them given information. So what is a displacement time graph? A displacement time graph shows over a period of time how an object's displacement changes. Okay, so time is shown as the horizontal axis, displacement is shown on the vertical axis. The most important thing that you need to know about a displacement time graph is that the velocity is given by the gradient of the graph. Okay, and what is velocity? Velocity is the change in displacement over change in time. Okay, so that's how you can find velocity. Now, how do we interpret displacement time graphs, or sections of them? So let's say we had a flat bit in a displacement time graph. So if we had a completely horizontal line, then what that suggests is that the object is at rest. Now, why does it suggest that? Or why is that the case? Because if you look closely, the gradient of this line is zero. It does not have a steepness associated with it. Therefore, if the gradient is zero, then velocity is also zero. So if the velocity is zero, the object is not moving at all. Okay, it's not being displaced at all. Okay, what about an object moving constant velocity? So if we had a section of the graph which was a line which had a constant gradient, the same gradient all the way through, then in the context of a displacement time graph, we say the object is moving with constant velocity in this time period. Okay, as I said, this is only the situation if the gradient is the same all the way through. Now, if the object is accelerating, then the graph will look slightly different. It will have a curved nature to it. The reason for this is acceleration is the rate of change of velocity over time. Okay, so that is telling you that the velocity is changing over time, and therefore, obviously, that the displacement is also changing over time. Okay, so if the object is accelerating, it's starting from zero, the velocity is changing at a rate, and therefore it will not be a constant velocity, it will be an increasing velocity, which will look like that. Okay, so that's the basics, and that's how we should be able to interpret displacement time graphs. So if we've got this example here in front of us, okay, so Tracy cycles from Aycliffe to Bedford, distance of 3 miles, so it's good to underline things. So she cycles from Aycliffe to Bedford, distance of 3 miles. She does that in 16 minutes. She then rests for 10 minutes before continuing to Seville, a further distance of 4 miles, which takes 20 minutes. Simon walks the same journey, does not stop for rest, and takes 2 hours. If Tracy starts out 15 minutes after Simon, that's quite important, when and where will she overtake him? Okay, so it's important to see what information we've got at the moment that could help us. So the first bit of information that we have is that Tracy cycles from Aycliffe to Bedford, a distance of 3 miles, done in 16 minutes. Now, before we even start that, what we're going to do is we're going to do Simon's journey first. I think that's the easy journey. So he does the same journey. Tracy goes from Aycliffe to Bedford, distance 3 miles, and then rests. So altogether 7 miles. Okay, so Simon does 7 miles in 2 hours. So 2 hours is here, 120 minutes. Go all the way up to 7, which is roughly there. Okay, obviously if he's walking, he's not stopping, then he's starting from here, which is 0, 0. He's going to carry all the way through. Okay, so that's Simon's journey there. Then we then got to think about Tracy. Now Tracy starts 50 minutes after Simon, so if we look at this axis here, 40 minutes, Simon will do this journey here, So Simon, 40 minutes is there. Tracy will start roughly here. Okay, so she'll start 50 minutes later after Simon. So she cycles from Aycliffe to Bedford, distance of 3 miles and 16 minutes. So we've got to look at the axes here. Just want to make sure this is all correct. 2, 4, 6. Yep. So it's going up in twos, and she does 16 minutes. In 16 minutes she does 3 miles. So we've got to go to 66, which is 62, 64, 66. And at that point, 16 minutes later, she's done 3 miles. She need to go all the way up to I think I just have a look at this and make sure it's all correct. Yep, it does that. Okay, so we can do that part of the journey. Then it's given that she rests for 10 minutes. Now if she rests on a velocity time graph, that obviously means we need a flat horizontal line. Okay, so she rests for 10 minutes, so from 66 to 76, 78, 76. Okay, she rests for about 10 minutes here. Okay, and then after resting, she continues on to Seville for a distance of 4 miles, which takes 20 minutes. So now we're at 76, and 20 minutes will take us to 96, which is here. Okay, so she does that. She then needs to go there. So if you draw those points together. Okay, and that is Tracy. So that is a displacement time graph for Simon and Tracy. Okay, and the overall question is, when and where will she overtake him? So Tracy overtakes Simon, and the point at which she overtakes him will be here. And she does that how many miles away from home? It looks like she does that. Make sure I get this right. 5 miles away from home. Okay, and how many minutes after does he set out and does he overtake? So 84 minutes after he sets out, and then obviously she set out 50 minutes later, so there's a gap of 34 minutes. Okay, so that's how we look at displacement time graphs. So again, the key factors are here on this page, and you've got to really read the question, understand where do you draw, a flat line for an object at rest, when do you draw an object moving with constant velocity, and how do you deal with an object accelerating. So at the bottom of this page there are some exercises which you can have a go at, and that's the end of displacement time graphs.